Next concept of engineering mechanics, maybe a third lecture of engineering mechanics, third video presentation about different laws of engineering mechanics. What are the laws? We are going to study about laws. It's a lecture 3 in engineering mechanics. What are the various laws of engineering mechanics? Where are the various laws of engineering mechanics? The basic laws of engineering mechanics are, what are the basic laws are? 1. Law of transmissibility. We are already discussed this law of transmissibility in the first lecture, lecture 1 of engineering mechanics. Next law is very important law. Parallelogram law forces. Next law is about parallelogram law forces. Next one, triangle law forces. Next one, polygon law forces. These two are an example. These two are about the two forces. When there may be two forces acting, we are go for parallelogram law forces or triangle law forces. And there may be only two forces are acting on a body, you can go for parallelogram law forces, otherwise triangle law forces. Both are same and equal and opposite. Okay, parallelogram law, otherwise triangle law forces. If there may be two or more, there may be two or more number of forces are there. Definitely we can go for polygon law forces. Polygon law forces, resolution forces. Already discussed a problem in the second lecture. By resolution of forces, we can learn the polygon law forces. We'll do the problem in this video also. Go for polygon law forces. First, law of parallelogram law forces. It states that if two forces, otherwise two vectors, no problem, two forces or two vectors acting on a particle at the same time, represented by magnitude and direction by the two adjacent sides of a parallelogram, drawn from a point, the resultant vector is represented in magnitude direction by the diagonal of parallelogram drawn from the same. According to the parallelogram law forces, what is the statement means? If the two forces are there, there may be magnitude as well as direction. Okay, which are acting at adjacent sides, adjacent to one another. The resultant is represented by the resultant of these two forces also represented by magnitude and direction by the diagonal of parallelogram drawn from the same point. The resultant of these forces is nothing but a diagonal of parallelogram. Proof. Now consider the two forces here. OA acting force is P, OD acting force is Q. Okay, OA and O. Now I am constructing the form of a parallelogram. This has been constructed in the form of parallelogram. What is the main property of parallelogram? Means parallelogram, two adjacent sides are parallel to each other. Both opposite sides are parallel to each other. That is one of the property of parallelogram. Now OA is parallel to DB. This is parallel to this one. And OD is parallel to AB. OD parallel to AB. That means whenever it is parallel, this line of action is remains same. That means line of action of OA and line of action of DB is same. That means OA is equals to DB. OA is equals to P and DB also equal to P. OD is equals to Q and AB also remains Q. From triangle AOD makes an angle theta. Whenever triangle AOD makes an angle theta, now this angle also remains same. Alternative angles are remain same. Whenever this makes an angle x-axis, with x-axis Q makes an angle theta. It is also Q. From x-axis makes an angle of theta. Now I am resolving forces into two components, parallel component as well as vertical component. Parallel component as well as the vertical component. Now whenever it is resolved, it is a vertical component, it makes an angle of 90 degrees. It makes an angle of 90 degrees. Now whenever this is theta, this angle is equals to theta. Now pi is the direction of resultant. Pi is the direction of resultant next with respect to x-axis as well as the resultant of force. Pi is the direction of the resultant next with respect to x-axis as well as the resultant of force. These are the basics of these are about that how to construct the diagram of parallelogram from the two forces how to construct a parallelogram. Already discussed in the previous slides. Now same discussion is going on here only. Let P and Q are the two vectors acting simultaneously at a point. At a point means it is passing through point O. Whenever it is passing through point O, means the forces are called as concurrent forces. We already discussed in the first video what is meant by concurrent forces means the forces which are passing at a single point. Represented both P and Q are the two forces, otherwise vectors, no problem, acting simultaneously at the same point, at the same point, not any point, at the same point, represented both in magnitude and the direction P and Q. Okay, directions, arrowheads also indicated. Magnitude and direction by two adjacent sides of OA and OD. By the two adjacent sides of OA and OD of a parallelogram OABD as shown in figure. I have shown the figure for you, a beautiful figure. In order to understood, let theta be the angle between P and Q. R will be the resultant vector, resultant force. R will be the resultant force. Then according to parallelogram of vector forces, parallelogram of forces, diagonal OB represents the resultant of PQ. OB represents the diagonal OB represents the PQ. OB represents the resultant. Now from that we can write as resultant R is equals to summation of two forces. R is equals to P plus Q. Next. Now comes to the mathematical expression. How to find out the mathematical expression. Now consider the parallelogram, whatever the discussion has been going on in the first slide. This discussion of the same. Now the same parallelogram I am placing here. Now from triangle OBC. Where is OBC? Can you show? OBC. Right angle triangle or kada? Yes. OBC is a right angle triangle. Perfect. Triangle OBC is a right angle triangle. From this, OB square is equals to. You know that Pythagoras theorem. Pythagoras theorem is OB square is equals to BC square plus OC square. OB square is equals to OC square plus BC square. No problem. OC square plus BC square. That is using that one. OB square is equals to OC square plus BC square. From that, OB square is equals to I am writing in place of OC OA plus AC. No problem. OA plus AC. OC can be written as summation of OA plus AC. OA plus AC whole square plus BC square. Now OB square is equals to applying A square plus B square formula here. A square is OA square, B square is AC square plus 2 OA AB, 2AB plus 2AB. A place lo OA undi and in place of B, AC. A square plus B square plus 2AB plus remaining is BC square. Consider it as first equation. Consider it should be as the first equation. Next. From triangle ABC. From triangle ABC. Okay. Then triangle ABC makes an angle of theta. Now we can write as using the Pythagoras theorem again. AB square is equals to AC square plus CB square. AB square is equals to AC square plus BC square. Right? AB square is equals to BC square plus BC square. Otherwise CB square. Now OB square is equals to this one first equation. In place of AC square in first equation, substitute in the first equation. This has been substituted in the equation 1. In place of AC square plus BC square, AC square plus BC square, I am substituting AB square. From this, OB square is equals to OA square, AC square plus BC square is equals to AB square plus 2OA OC, 2OA OC. Consider it may be a second equation of second equation. From triangle AOB, from triangle AOB, there is AOB. Is equals to theta. Okay, next step. But triangle ABC, triangle ABC, triangle ABC is equals to theta. Triangle ABC and the triangle AOD, angle ABC and angle AOD is equals to theta, because both are remain same angle. Now in triangle ABC, you can write as cos theta is equals to AC divided by AB. Right, can write or not? Cos theta is equals to AC divided by AB. From the AC is equals to AB cos theta. From triangle ABC, in triangle ABC, AC is equals to AB cos theta. Now, this has been substituted in equation 2. It has been substituted in equation 2. From this, OB square is equals to OA square plus 2OA. In place of AC, I am substituting AB cos theta. In place of AC, AB cos theta plus AB square is equals to, now OB square is equals to R, OB is equals to R, OA is equals to P, OA is equals to P, AB and OD is equals to Q, AB, OD is equals to Q. Now from that, OB square, in place of OB square R square, OA square, P square, in place of 2OA, P, AB, Q, cos theta plus Q square, R square, P square plus 2PQ, OA plus OB is nothing but PQ, cos theta plus Q square. From that, R is equals to square root of P square plus 2PQ cos theta plus Q square. Next. What about the direction of resultant? Direction of resultant, let phi be the angle made by the resultant P. Already discussed in the diagram. Phi be the angle made by the R and P, that is resultant as well as the force P. Now from triangle OBC, what is the triangle OBC? From triangle OBC, tan phi is equals to BC divided by OC. Tan phi is equals to opposite side is BC, adjacent side is OC. BC by OC. From that BC is equals to BC divided by OC can be written as OA plus AC. Now tan phi is equals to, now BC can be written as Q sin theta. From triangle ABC, sin theta is equals to BC divided by AB. From that, BC is equals to AB sin theta. Avuna kada? AB sin theta. AB enta Q. Andukane nenu BC place em rasanu? Q sin theta rasanu. Now tan phi is equals to Q sin theta divided by, in place of OA, OA is equals to P, and from the previous slide, AC is equals to Q cos theta. Now it has pi is equals to tan inverse of Q sin theta plus P plus Q cos theta.